Cracks going sideways, but the cracks are curved. In the northern hemisphere, they curve to the left. In the southern hemisphere, the crack curves to the right. And at the equator, it's disturbed. They go all directions. It's the Coriolis effect. How many people know what the Coriolis effect is? A couple? You guys haven't taken that in school yet, have you? Okay. You've seen hurricanes from a space satellite? You notice how in the northern hemisphere they go counterclockwise, in the southern hemisphere they rotate clockwise? That is caused by the Coriolis effect. It's actually caused by the spin of the Earth. In this case, apparently the continents slid east and west of each other. Again, I'm going to show you how and why later on. But they slid east and west of each other, and as they did, the cracks actually followed the Coriolis effect. Here's the catch. The only way Coriolis can work is if it happens at high speed. In other words, today we're told that the continents are dividing from each other at roughly the rate a fingernail grows. Not very fast. According to Dr. Walter T. Brown's model, which I'm going to talk about later, the continents actually moved apart at up to 45 miles per hour. He's actually done the math. That is fast enough for Coriolis to take effect. So what has happened is on the east coast of Canada and the United States, you can actually see the mountains have rotated. And so consequently, within those layers of the making up the mountains, you have all these upright plants. They have also been twisted by the Coriolis effect. It is all evidence of rapid continental division, catastrophe, if you will. Okay, how many people have been to Washington State? One or two? Okay. You may or may not have seen this. When you're heading out there on the interstate, I forget which interstate this is, you see some pretty spectacular sights. This is the Columbia River Gorge, and these are all lavas. In other words, this was all molten rock that poured out onto the surface of the land. It's up to 10,000 feet thick. Huge lava flows. There's actually several out on the west coast. Now here's the catch. They have ball pillows, or pillow lavas all over the place. Guess how pillow lavas are made? Underwater. Who said that? Good man, you passed the test. All right. He's right. Pillow lavas are made underwater. Wait a minute, 10,000 foot thick lava flows? Some 3,000 to 4,000 feet above sea level or more? And they were poured out in vast quantities underwater? We're talking global catastrophe during a global flood. That's what it is. Here's a map of those lava flows alone. There's also the Snake River lava flows, which actually I think are included in those. At any rate, here's my point. We do not see catastrophic lava flows like this forming today, and if we did, it would be a study in catastrophe, not long and slow geologic processes. Anybody recognize what these are? Want to take a guess? Go for it. You got it. Yeah, that's it, exactly. Do you know what the ones that grow from the cave floor are called? Stalagmites. Okay, easy way to remember. Stalactites stick tight to the ceiling. Stalagmites might get to the ceiling. Really easy way to remember, okay? Now, conventional geologists in the past have said that these stalactites take thousands of years to grow. In fact, not far from my home, there is a cave, a Turin cave, and when you take a tour in that cave, they tell you the stalactites grow at roughly 1,000 years per centimeter. Now that one there is about 12 centimeters long. That's stalactite. So going by that assumption, How old should that stalactite be? At 1 centimeter for every 1,000 years, 12 centimeters long. 12,000 years. Old, right? Give or take. Well, I mean, again, what's 1,000 years among friends, right? Okay. Here's the catch. I handpicked these stalactites from a hydroelectric dam built in the 1950s. There they are right there. You can even recognize on the far left side this one. Can you spot it? So the evolutionists, or should I say anti-creationists, got very irate. They came back and responded, oh, it's not the same chemically, it's this totally different growing process. Well, actually, we took samples of these stalactites to a lab in Calgary, Alberta. And we had X-ray diffractometry done on them. Big, long technical word for you, don't worry about it. There's the analysis right there. It is calcite, almost completely pure. Now, interestingly, my buddy Vance Nelson, who owns the other traveling creation museum in Canada, he and I collected stalactites from all over North America from man-made structures, bridges, dams, etc. Interestingly, the ones that were the smallest and took the longest to grow were the ones that were most different from caves. The ones that grew the fastest were the ones that were the purest and closest to cave stalactites. So in other words, no, it doesn't take thousands of years. All it takes is one change in one condition, more water. That's all it took. And we demonstrated this chemically, showing they're no different than cave stalactites. The process, the chemistry, everything is exactly the same. Doesn't take thousands or millions of years, and stalactites certainly do not prove that the Earth is millions or billions of years old. What do I got next? Oh, yes, okay. And here's another sample I got with me. I think some of you actually figured out what this was. Did any of you ladies take a look at this already? Or do you have any guesses as to what it is? It's pretty simple. It's wood, yeah, exactly. Okay. See, was that simple or what? Okay, this is a wood fragment. I know it doesn't look like much. This is supposedly a 40 million year old wood fragment. I can take my fingernail and run it into it. I can light it on fire. I can build a campfire with it. And in fact, the Inuit peoples up in northern Canada do this all the time. I interviewed a couple of Inuit that came down to my hometown of Pembroke, Ontario, and I said, I've been told there's trees up there. They don't grow up there today, by the way, in case you didn't know that. I said, I heard there's trees and wood all over the place. And she said, yeah, it's all over the place. I said, well, how did it get there? She says, I don't know. But they actually use it for campfires all the time. So this precious 40 million year old, they're burning it all over the place. Now here's the thing. This wood fragment came from a place called Axel Heiberg Island. There are polystrate stumps all over the place. You know what the term means now. There's the red star marking Axel Heiberg Island. You can actually take core samples of the tree rings. You can cut it with a saw. You can study the trees as they are sitting there. They are assumed to have been buried, as Joggins was, as they grew. The same as Joggins, the roots are gone. It's very rare to find a stump with roots still attached. Obviously, they didn't grow there. They've been ripped up and transported there by a flood. But here's the thing. This wood tells a very interesting story. These are micrographs of the tree rings. Now, down here on the bottom, these are the tree rings from a redwood tree in British Columbia today in a temperate climate. So at the beginning of the growing season in the spring, this is a ring, this is a ring, and this is a ring. So if you were to follow it around, the ring goes around in a big circle and then comes back, okay? So in the springtime, the tree grows a fast, soft layer called the early wood. And you can actually see it there, the whiter stuff. Look at the size of the cells. They're huge. They're big, soft, celled layers. And then, in preparation for winter, it grows a thick, hard outer layer called the late wood. And you can actually see it, and then it stops for the winter, and then starts growing again in the spring with the early wood. Late wood stops for the winter. Early wood, late wood stops for the winter. You follow me so far, right? Okay. Here is a sample of one of the tree rings from the Axel Heiberg wood. The tree rings are so indistinguishable, they actually had to mark it in the photograph. There's one, there's the other. First thing you'll notice is it's to scale. What took a tree in modern times in a temperate climate, what took a tree 5 years to grow, the Axel Heiberg trees grew in 1 season. This is in the Canadian high Arctic. It's nighttime for half the year. The temperature in the wintertime gets down to 40 below regularly. It is not a wonderful environment for trees, okay? Now, on top of that, you'll notice there is no latewood. These trees, it's as if they did not experience winter. In what a place right now, which is winter for more than half the year. It's not just the winter, but it's also the light. You got to remember, this is on the North Pole. Even during the summer, the land of the midnight sun, even in the summer when the sun comes up, it's still very low on the horizon. And if you have a whole pile of trees, they're going to produce a whole pile of shade. Trees need light. Not just light, but light intensity. These trees had no lack of light, no lack of water, no lack of nutrients, no lack of warmth. The present cannot be the key to the past, because today, that is not the conditions we see in the Arctic Circle. Now, personally, I think those trees were actually floated there by Noah's flood. Now, get a load of this. Lindsay Williams, a couple of years ago, wrote a book called The Energy Non-Crisis. It was actually a conspiracy book. He was a chaplain on board the Alaskan pipeline, the Alaskan oil pipeline. He was actually a chaplain on board the construction crews for that pipeline. And he made mention of a whole pile of fascinating little tidbits of information about the high Arctic. So they're up on Prudhoe Bay, the north slope, the very far north shore of Alaska. This is as Arctic as it gets. But get a load of what he said. There is an interesting point to mention in passing. Though the ground is frozen for 1,900 feet down. Wow. That's some serious permafrost. Though the ground is frozen for 1,900 feet down from the surface of Prudhoe Bay, everywhere the oil companies drilled around this area, they discovered an ancient tropical forest. Bizarre. It was in a frozen state, not in petrified state, very much like the wood we find at Axel Heiberg. It's been preserved by freezing, not fossilization. It's between 1,100 and 1,700 feet down. There are palm trees, pine trees, and tropical foliage in great profusion. In fact, they found them lapped all over each other just as though they had fallen in that position. Well, that's kind of weird. It is also interesting to notice that tropical ferns have also been found at the Antarctic, and the evidence from these two areas, considered together, certainly suggests that there has been a dramatic change from a worldwide tropical climate to an Arctic climate within datable times. It is also interesting to remember that the great Arctic explorer Admiral Byrd reported seeing tropical growth in near Arctic regions. The present cannot be the key to the past. We do not have a whole pile of tropical vegetation growing in the North and South Pole right now, do we? And furthermore, we find things like, if I have it with me, that's not it. Aha, that's it. That's not much, I know. Well, heck, I'll pass it around just so you can get a look at it. This is actually a cast of an armor plate from an animal called a glyptodont. Now again, we were talking about things being bigger in the past. I'll pass this around. But this armor plate comes from an armadillo, basically. But this armadillo was found in the Antarctic. Now, do we have armadillos around here in Illinois? Why not? Because armadillos hate the cold, right? The cold and armadillos do not get along. Usually the armadillos lose to that one, okay? And you know where armadillos normally live? Down in Texas, you see them quite frequently. They're a small flat creature that lives in the middle of the road. Yeah? Okay. Anyway, I'll pass this around. If you were to see this armadillo and run over it with your car, you would lose. This armadillo is roughly the size and shape of a Volkswagen Beetle. Okay, it's not a small armadillo, okay? But that's one of the armor plates. I'll just pass it around, see whoever sees it. But again, what's an armadillo doing in the Antarctic? It's not like it's going to float there. So the one explanation, the logical explanation, is that that is where it lived, that's where it died, and that's where it was buried.